Okay, well, we're going to go ahead and get started here right at about 1 o'clock. We've got a few more people trickling in. So first we'll go over some housekeeping notes. Thank you for joining us today. My name is Sean Maurer. Joining me today is my colleague Ryan Siegel. We'll be reviewing a comparison between ASHRAE 90.1 2019 and the 2018 IECC, looking specifically at the lighting and electrical section. As we're going through our presentation today, if you have questions, please enter those into the Q&A window. If you hover at the top center of your screen, you should see the Q&A menu option there. If you enter those questions there, make sure that we receive those questions and can account for them. If you enter the questions in chat, we may miss answering your question. As we are touching on the comparison between the 2019 ASHRAE and 2018 IECC, just be aware that many of these comparisons will also apply to updates to the 2021 IECC. As we go through the presentation, we will try to highlight those for you. So a couple of things we're covering today. We're going to understand the relationship between the organization of the IECC and ASHRAE 90.1, help you to figure out how to navigate more quickly between the two. Understanding the similarities and differences between prescriptive lighting power density requirements between the two compliance methodologies, similarities and differences between the controls requirements is a particularly tricky part as they are organized quite differently between the IECC and ASHRAE. So we'll be covering that in some detail, and then understanding daylighting controls as well. CDAC is a preferred education provider through the IECC, so credits can be earned on completion of this program. We also provide continuing education credits for AIA. Once we complete this webinar and have our slides and presentation materials prepped, we will send you an email with a attendance certificate. You can reply to that email with a link to a form, provide your AIA member number, and then we can submit those credits for you. The Smart Energy Design Assistance Center is an applied research program at the University of Illinois with the mission to reduce the energy footprint of Illinois and beyond. And the Energy Codes training program is just one of many programs that helps us achieve that mission. We want to thank the Illinois Environmental Protection Agency's State Energy Office for sponsoring this training program. They also help sponsor our technical assistance for the Energy Codes, and so we thank them for their support. Our training program also provides technical support as noted. So for code officials, architects, engineers, contractors, building owners, if you have a question about the Energy Code, you can reach us at energycode@illinois.edu or the 1-800 number. We also have a number of resources available online at our website, smartenergy.illinois.edu/energy-code. If you do have a question, we do prefer that you send us an email and specify whether it's a residential question or a commercial question, as that helps us refer to the correct portions of the code. But if you do need a quick answer, that 1-800 number is available. Emails give us a little bit more time to dig and do some in-depth research for you and get you the most accurate answer we can. If you go to our website at smartenergy.illinois.edu/energy-code. This is a listing of the available resources we have there. Recordings of our previous webinars and workshops are available there, as well as downloads for the slides. We also have self-paced online training courses, including a new offering, the Building Energy Efficiency Fundamentals courses. We also have links to our technical support line there. Probably the most helpful is the Energy Code resources, where we have direct links to the Energy Codes themselves. So you don't have to remember these long URLs. You can link from our website directly to the IECC most current version, the Illinois amendments to the IECC, and the Chicago amendments to the IECC. So you have direct access to those Energy Codes. When accessing ASHRAE, they do have free preview versions available, similar to the IECC, through their webpage. The URL link is listed here. You cannot directly access into a code. You have to go to this link and then scroll down through the page to find the standard that you wish to reference. The most current standards are at the top of the page. So as you're scrolling down looking for 90.1, the first one you will run across is the 2019, the most up-to-date version. If you're looking for the 2016, so that you can refer to ASHRAE in comparison to the 2018 IECC, that is further down the page. Something we do like to note is that the IECC's webpage has a very robust search function. You can search in the ASHRAE, but it's not quite as robust as the IECC's, but that functionality is there as well. So looking at compliance options, the ASHRAE 90.1 standard is one compliance path that can be used. In Illinois, ASHRAE is a standard that can be used to show compliance, but it is not the energy code. The IECC is a code. It's adopted by law, by authorities having jurisdiction over the ways buildings are constructed. So it's an important distinction there. The IECC is a code. It is adopted by law. ASHRAE is adopted inside that code as a standard for showing compliance. This webinar or workshop is part of a series comparing the 2019 ASHRAE 90.1 to the commercial provisions of the 2018 IECC. Today we are covering lighting and electrical. Later in May, we'll be covering performance-based compliance again, and we have previous recordings for mechanical and envelope systems on our webpage. We'll also be covering later this month building energy education for architects. We'll be looking at renewables and the zero code, getting buildings to net zero through code applications. We'll also be touching on passive house later in May as part of that education series. And then at the end of May, we'll be touching on the 2021 IECC updates as we want to be as current as possible with updates, amendments that are working through CBD. So we're going to do that as close as possible to the application deadline for that 2021 IEC updates. And then we'll also be doing a presentation on testing and verification, how to ensure your buildings are complying with the energy codes in June. So as noted before, there are two compliance paths for compliance with the Illinois Energy Conservation Code, one being direct application of the compliance paths of the 2018 IECC, the other being the compliance options in the ASHRAE 90.1 standard. Some clients have elected to use a newer version of the ASHRAE standard to increase their energy savings as it has some improvements. But for specific compliance with the 2018 IECC, the reference standard is ASHRAE 2016. 2019 will be the reference standard for the 2021 IECC when looking at ASHRAE compliance pathways. Just an overview of the overall organization between the IECC and ASHRAE. We're going to be looking at Chapter 4, Section C405 of the IECC. That's the lighting and electrical compliance, and touching a bit on existing buildings in Chapter 5. The key thing here to note is that IECC does break out existing building requirements in a separate section. And then lighting and electrical is grouped in with the main prescriptive requirements in Chapter 4. As we look at the ASHRAE organization, it has an additional section on power requirements. A lot of these are going to be added in the 2021 IECC and a section for lighting. But within those sections, they have the mandatory requirements grouped first, then the prescriptive requirements, and the existing buildings requirements are all built into those sections. So they're not in a separate chapter like in the IECC. In some cases, this can make referring to the requirements for existing buildings a little bit easier to reference in ASHRAE, and also can make referring to mandatory requirements a little bit easier as they have a dedicated section with each component of the building. But today we are focusing on lighting and power requirements. Um, the layout within these sections is very similar for the IECC and ASHRAE as far as the compliance pathways. Um, when looking at the ASHRAE organization overall here, power and lighting both have the same general organizational layout with general requirements being listed first, definitions of the compliance pathways in the next section, the mandatory provisions, and then moving into the prescriptive pathways and alternate compliance pathways, and then the performance pathways such as the energy cost budget and Appendix G. Those are all followed up by required submittals and documentation. Um, and so similarly to the IECC, IECC's organization has the mandatory requirements interspersed throughout the section, although for the lighting section, most of the sections of that are mandatory provisions. Before we move into our next section, we do have a quick poll here. We just want to gauge your overall familiarity with 90.1. So have you seen or used the 90.1 compliance option before? And how comfortable are you with the 90.1 versus the IECC? We did have a note in case there were questions. The Illinois' original target date for adoption of the 2021 IECC was June 1st, but based on the present status of adoption, it looks like that's going to be delayed until late in the summer. Okay, go ahead and share those poll results. Looks like we got a 50-50 split on people who have and have not seen the ASHRAE compliance pathway before. Looks like most people are more comfortable with the IECC. There are about 12% there that know the ASHRAE pathway better. Thank you for that information. So moving into, as we're looking between ASHRAE and IECC, one of the key things here is that ASHRAE has power requirements that are not in the IECC. So we'll cover those. And again, where these are coming in the upcoming 2021 IECC, we'll try to highlight that for you. So one of the big differences between the IECC and ASHRAE that a lot of people pick the IECC for compliance is receptacle control in the ASHRAE requirements. At least 50% of receptacles in private offices, conference rooms, common building areas with plug loads and phantom loads resulting from the plugged in equipment must have receptacle controls. A lot of time buildings have been able to address envelope HVAC and lighting loads through the IECC and avoid this receptacle control compliance option. But again, this is coming with the 2021 IECC, a large component of this. These electrical requirements for receptacle control work to address the load that has not been reduced in buildings through that IECC compliance path and are becoming, with more and more efficient buildings, a larger component of the building's energy consumption. So with newer technologies, to implement these receptacle controls in buildings, there needs to be some substantial communications campaigns to avoid occupants defeating the purposes of these control devices. People need to be aware that controlled receptacles are in place, so things like labeling them properly and clearly, making sure that building occupants and owners know that these controlled devices are in place before they start using the facility is going to be very important, so that people don't bypass these controls by various different methods that we've seen in the past for buildings that do have these in place. Being aware too that certain things should be plugged into receptacle controls and certain other things shouldn't. Mission critical things like server devices and things like that should not be in a controlled receptacle if it's needed 24/7. Standby devices like monitors and printers and things of that nature, that aren't needed 24/7 when they're not in use. They generally go into a low power state anyway, with a lot of computers and devices having Energy Star standards for low power standby states. Those are the kinds of items that these control receptacles are looking to minimize phantom loads for. And so, as noted, this is coming in the 2021 IECC. Something else that ASHRAE contains that is coming in the 2021 IECC is sub-metering or monitoring of electrical systems and HVAC systems. So these measurement devices are going to be installed in new buildings. They'll have to monitor total electric energy, HVAC systems, interior lighting, exterior lighting, and then receptacle circuits. It can be very useful for troubleshooting and identifying issues in a building, as if you have sub-metering of individual systems and an individual system has an issue, you can see that in a blip in its energy performance trends. So the intent of these kind of monitoring controls is to assist in long-term commissioning of the building and maintaining its performance over time. Data for these monitoring systems needs to be held for at least 36 months. So again, you can do that kind of comparative analysis and have the ability to do some in-house commissioning of systems. Recording and reporting data for tenant spaces is where this is particularly being applied. Electrical energy for all loads specified in section 8.3.4.1 shall be recorded a minimum of every 15 minutes and reported at least hourly, daily, monthly, and annually. Data for each tenant space shall be made available to that tenant. Particularly important for like strip malls and places like that. Large office buildings with multiple tenants in it, so that individual tenants can know how they're performing in their facility. Buildings with a digital control system installed to comply with the BAS requirements of the HVAC section of the standard. That energy use required in this section shall be transmitted to that control system, so you have a central repository for data monitoring and tracking. There are some exceptions to this requirement, generally smaller buildings, so looking at buildings less than 25,000 square feet, individual tenant spaces that are less than 10,000 square feet, dwelling units with residential buildings less than 10,000 square feet of common area associated in them, and critical equipment and branches of the NEC Article 517 are exempted from these requirements for data monitoring and reporting. Again, the main thing here is it's looking at long-term tracking of building performance and maintaining that performance over time, helping building operators and engineers figure out, is there an issue, quickly diagnosing where that issue might be through these trending requirements. Something else in ASHRAE that is not in the IECC is a service water pressure booster system requirements. One or more pressure sensors shall be used to vary the pump speed and or start-stop those pumps. The sensors shall be located either near critical fixtures to determine the pressure required, or some logic shall be applied that adjusts the set point to simulate operation of remote sensors. Devices shall be installed for the purpose of reducing the pressure of all water supplied by a booster system pump or booster system, except for safety devices. So if you're boosting the pressure up, you don't want to be boosting it up really high and then throttling it down somewhere else with a pressure reducing valve. This is kind of working towards properly sizing these pressure boosting systems and not oversizing them. And then no pressure booster system pump shall operate when there's no service water flow. You don't want to burn the pump up. So kind of a best practice, common sense requirement there. And then lastly, looking at clean water pumps and those control systems, there are some requirements in ASHRAE. I won't go through all of these in detail, but for pumps meeting these certain requirements, they have to meet the requirements shown in a table in ASHRAE for motor efficiency. Um, the standards of that section do not apply to fire pumps, self-priming pumps, prime assist pumps, magnet-driven pumps, pumps designated for use in nuclear facilities, um, and pumps meeting specific U.S. military specification requirements that are already anticipated to have higher efficiency associated with them. But again, this is just looking at for pumps that typically have higher operating hours and conditions um, that they meet specific efficiency requirements. Then lastly, an interesting addition in the IECC that's not in ASHRAE, kind of a rare situation here. Usually ASHRAE has requirements not in the IECC, but in this case, it's the other way around. The IECC does have requirements for escalators to have regenerative drives. So escalators that are bringing people down in a facility once they hit this weight capacity requirement, they're anticipated to have enough energy in that gravitational potential of the riding occupants that a regenerative drive will supply some energy back to the building at a cost-effective means. And so just an interesting addition in the IECC. Not sure if this will be coming to ASHRAE in the future or not yet, but it is important to be aware that this exception is in the IECC and not in ASHRAE. So before we move on to the lighting requirements, we have another poll here. So what categories need to be monitored under the 2019 ASHRAE 90.1? So thinking back to the monitoring and reporting of electrical systems, total electric energy, HVAC systems, interior lighting, exterior lighting, receptacle circuits, or all of the above. And then where is automatic receptacle control required in 90.1? Anywhere occupant sensing controls are required, offices, conference rooms, classrooms, etc., outdoors, habitable rooms and corridors, or everywhere. I don't see any new questions have come in yet. Give it another second or two. Got a couple of responses coming in still. Okay. So the first question, what categories need to be monitored? It is all the above. So all of those do need to be monitored and tracked. Again, looking for tracking of building efficiency and performance over time. And then for our second question, where is automatic receptacle control required? It is offices, conference rooms, classrooms, etc. Looks like most people got that one correct. Okay. With that, I will turn it over to Ryan to go over the lighting requirements.
Well, thank you, Sean. With lighting in ASHRAE, a lot of this is going to be a layout difference for here. So understanding that with ASHRAE, they give you a few different ways to handle lighting and lighting controls. One that is new for this generation is the simplified building compliance path. So this is specifically for only certain building types, classrooms, schools, and offices being two of those that may use this simplified building compliance path, which trims down the requirements to only a few pages rather than an entire section of the ASHRAE 90.1 standard. And it covers very similar things, but distills down and removes several of the items that may be more specific to other building types that are more less common situations. So building area method is the method that we see most common. This is, again, a little bit more simplified uh, and covers the entire building in a calculation. Uh, Alternatively is using the space by space method, which has categories of individual space types. So the space by space method generally gives you a little bit more power uh, than the building area method for your budget. However, the calculation is substantially longer because you have to break it down into all the individual space types. Uh, Whereas a building area method might just say hospital. The space by space method may break that would break that down into like surgical suites and nurses stations and corridors and a few other types. So, but one to make people aware. So if you are in offices and schools, and I think perhaps retail is in there as well. Uh, for those projects, you might check the simplified building compliance path. So looking at one of these tables, so trying to compare some of these different ones. Noted here, the simplified building method just gives you a little bit more uh, direction and directness of it. Uh, so uh, they do give you a slightly different lighting power density allowance, uh, but it doesn't give you some of these exceptions that may allow you to increase that lighting load a little bit. Also here noting for the control mechanism that most all of these are partial or manual on, and others do allow you the full auto on. Uh, so, and daylighting controls, here there is an exception again in the simplified building method that you don't necessarily require those daylight harvesting controls for buildings. Now, understanding as technology improves, implementing daylight harvesting controls has become a more easy thing to accomplish with this. So uh, in here, if you are using the building area method or the space by space method, there is a table that specifies the on and off controls that are required for this. So here noting one of the thresholds is at least 80% of the floor area needs to be the primary building type of office buildings, retail, or schools to be eligible for this simplified building method. And it can also be used for tenant improvements where you have a smaller tenant going through an upgrade. So tenants of under 25,000 square feet can be handled kind of on their own through this. So here's a little bit of a look at this using the office building type. Here we have a lighting power allowance of 0.7 watts per square foot throughout the area. And then the controls, it's just specifying here's what controls you're needing for the space type. Here specifying for spaces in the office buildings other than parking garages, stairwells, and corridors. Going to have an automatic off controls and throughout this, the lighting load, there is an allowance to leave some lighting on. This provides for egress and other types of needs that you may have in a building to make sure that people can leave safely, even if the lighting controls have turned off. So, The simplified path also has its own table for exterior lighting power allowances. And what we like to make sure that people are aware of is for most people and most projects, these are going to be in zones 2 and 3. Zones 0 and 1 is for uh, rural and uninhabited locations. Think national parks and things like that that are more natural areas. So that's your zone 0 and 1. Zone 4 is for heavy commercial in major metropolitan areas. So zone 4 will only be found in certain locations within the city of Chicago here in the state of Illinois. Uh, so everywhere else here in the state of Illinois is going to be in zones 2 and 3. How you're differentiating between zone 2 and 3 is zone 2 is more residential, zone 3 is commercial. So if you're not totally sure where you are, if you're dealing with a zone 2 or zone 3 project, feel free to reach out to your building official and they can help provide you guidance. If you think you might be right on the border, they can help make that determination with you. So as we see here, as we get more commercial and urban, the power allowances do increase, understanding that you do have substantial lighting pollution and other things in the area as you get more urban, whereas if you're out in more rural areas, you're having a lot less competition for your lighting. So for those not using the simplified method, here's where you get into the space by space method for what the controls have to be. And here in ASHRAE, they have several that are required. And then you'll see here there's add ones and add twos. This doesn't mean that you have to add one of B or C and then add two of H or I. What this is this is add one of each of these two categories. So I need to add either category B or C, and I need to add one of category H or I. So add one of category 1 and add one of category 2. So it can be a little bit confusing as we're going through here. But with add 1, understanding that add 1, it's based on how this is controlled for turning on. Either this is going to be manual on, or if it's automatic on, it's only partial. So it's going to be a 50. You cannot not bring it on automatically to more than 50% for specific spaces. So, and then something that ASHRAE does a little bit different is if you do add some additional controls, then you can add some additional lighting power allowances. For those of you who are a little more familiar with IECC, they may typically have a little bit higher lighting power allowances, but do allow you to trade a reduced lighting power allowance for less control. So these operate in similar fashion, practically speaking, but they're worded differently from each other. So again, for ASHRAE, if you add more controls, then you can get a little bit more power budget. So ASHRAE also has some things for if you have unusual room geometries, a room cavity ratio. So if you have unusually long rooms or unusually tall rooms, through this RCR calculation, you can increase your lighting power density if you do have one of these more extreme room geometries. And part of this is accounting for light bouncing off of walls if you have unusually tall spaces, you're not able to bounce that light off the walls. And similarly, if you have unusually long rooms, the walls will end up absorbing a lot of that light that would otherwise reach the floor. So that's part of the reason why they've added these in. And you may have seen there, it gives you about an extra 20% if you do need that. So here, what we're looking at is we've got a 40 foot by 40 foot room, total room height of 20, and the cavity between the luminaire and my work plane here is specified as only 8 feet. So because I have a very tall room relative to my fixtures, that or because my fixtures are not using up that large room height, I end up where I'm not gaining that or not needing that extra bonus budget. If I did move the fixtures much more towards the ceiling, then I might cross that threshold. So here the room cavity ratio calculation showing calculation of 0.5. And in order to cross that threshold for a classroom space, I need to be above 4. So as you can see, these are rather some rather extreme cases. Here is a similar, different type of classroom setting, but here we've got a very tall room at 35. And the fixtures are all towards the ceiling. So my room cavity at 32 feet going through the calculation gives me the room cavity ratio of just under 13. So here we do get above that 4 threshold. So I do have that extra budget in there. Manual controls, ASHRAE does have manual control requirements, which as we think through this, having manual controls, even if I do have automatic controls, is good practice just from the standpoint of we want occupants to have the capability to turn the lights off when they're not when they're not needing them. So you may have occupants that are in the room, but they may not need the lights, either because of windows or because of the type of work they're doing. So if they're doing a presentation and trying to have read a screen that's on the wall, having the ability to turn those lights off and have that manual control for the occupants is very beneficial for them. So, here they do call out some requirements here as far as making sure that your zones for controls are not larger than 2,500 square feet. If you do have smaller spaces, if you do have larger spaces that are over 10,000 square feet, then these manual control zones should be no larger than 10,000 square feet per zone, which one place could think of this being applicable would be if you've got shopping malls and you've got certain zones of the shopping mall that you're working in, not requiring someone to turn on and off the entire mall and having control zones that are more reasonable. So here having the 2 different thresholds depending on your space type does provide a little bit more granularity and tries to balance the cost of that granularity with the benefit of having that. So with that, let's do a little bit of examples as far as some of our controls. So here looking at a meeting space, 20 foot by 40 foot. So we've got 800 square feet of room space. Total lighting load in this space is 200 watts or 1/4 watt per square foot. Ceiling is 7.5 feet tall and I've got windows that are 7 feet off the floor, and got 7.5 square feet of window or fenestration per window, and we have 4 windows in this space. So this is kind of the sample room that we're going to look at for reviewing these controls. So first, as we're looking at, is continuous operation necessary for safety or egress? Uh, being that this is a meeting space, we don't have to have 24/7 lighting for safety and or egress. If we did, then controls would not be required. Typically for continuous operation, these are going to be, and for safety, this is going to be perhaps hospitals, laboratories, some other areas like that, where if the lights were to go off, that would really be cause a safety hazard. So, since we are not required for continuous operation, we'll go on to question number 2. Is the enclosed space a small space? So 300 square foot or less, we mentioned it's 800 square feet. So it's not that first one. Or does it have unpredictable occupancy schedule? A meeting space probably is going to have unpredictable occupancy. It's not a very, not one of those, that it's going to be have occupancy from, 8 a.m. to 4 p.m. or something of that nature. An example of that might be kind of going back to that mall. We know what time the mall opens, we know what time it closes, so we have a very predictable occupancy schedule there. So for this, it does have unpredictable occupancy. So with that, it says, yes, we need occupant controls, and we're calling out here that the on is limited to only 50%. So I can't turn on all the lights in the space with an occupant sensor. If I want to do it automatically, only half of the lights or less could come on automatically. And then the user would have to interface with the controls to bring on the remaining lights. So we'll also notice the double star here is ASHRAE does call, or an IECC does call out that automatic on is allowed in certain spaces, your hallways, stairways, restrooms, and other safety applications. So understanding that when you're entering a bathroom, you don't necessarily want to be interfacing with those controls. So it does allow full automatic on. So if it did not have, or if it did have predictable occupancy, then you get into health and safety. Is there a concern of health and safety if the lights were to go off when they should not have? So if there is a health and safety reason, then you may just have light reduction controls. If not, then looking at time clocks with light reduction controls. It's now looking at daylight controls. So here again, continuing in the IECC. So first question, is the space adjacent to fenestration of at least 24 square feet or a skylight? We mentioned earlier, I believe those windows were only 7.5 square feet per window. So I don't meet that 24 square foot threshold. So because I don't, daylight controls would not be required for that space. So if we assume for a second that it was, then the next question is, does it receive, is there enough sufficient light? And that's dealing with, do I have blocked sunlight through adjacent buildings and other things, or is there more than 150 watts of electric light in that zone? So if we do get sufficient light and there's more than 150 watts, then we get into a question of, did I use reduced lighting power density? If I did, then I can avoid the use of daylight controls. Otherwise, if I did use uh, more of my power budget, then I would have to add daylight harvesting controls. As we move to the outside of a building, there's a few questions to check as far as exterior lighting controls. First is the lighting controlled from a dwelling unit? So this is in a commercial building, but you may have residential dwellings in a commercial building. Or is it a vehicle entrance for a parking garage? If it is, then you don't have to do any automatic setback. Presumably for the dwelling units, that's going to have your manual controls inside. Typically for a balcony, that someone's going to turn a light on when they go out and turn it back off when they come back in. So if not, then we need to look at sensors. So first, we do have to have a daylight sensor for exterior lighting controls. Then the second question is this lighting decorative? So that could be landscape lighting, facade lighting. Those are probably the two most common out there. If it is decorative lighting, then we need to have a timer, turn them off during non-business hours. And it does allow for, I believe, a 1 hour, an additional hour beyond your actual non-business hours. So if your store closes at 5 p.m., then the decorative lighting needs to be turned off by 6 o'clock. If it is not decorative lighting, then we're going to be using a time switch to reduce lighting power by at least 30%. This could be done in a few different ways, either through turning off some of the fixtures. It could be dimming some of the fixtures or combination thereof. So with that, let's take a look at some comparisons. We've got a poll question. So looking at our lighting controls here. So first question, in the ASHRAE compliance example for the meeting room that we talked about, that 800 square foot meeting room, which lighting controls were required? Occupant sensing controls, light reduction controls, manual controls, daylight harvesting controls, or time switch controls? And then our second question, which of these locations does not require occupant sensing controls? Classroom, laboratories, offices, spaces 300 square foot or less, or restrooms? Give it another second or two here for nice people to answer. Okay. Go ahead and share those. Occupant sensing controls was required, yes. Light reduction controls, we didn't have daylight harvesting, so we didn't have that. Manual controls, we do need to give people manual controls. Did not require daylight harvesting or time switch controls. So the majority of people did pick up on those two, the occupant sensing and the manual controls. And then which locations do not require occupant sensing controls? This was looks to be a little bit of a tricky one. Laboratories is the one place, one of these that does not require occupant sensing controls. Again, thinking safety here, we want to make sure in laboratories we don't we don't accidentally turn off the lights when people are still working. So small spaces do require them, as do offices, classrooms, and restrooms. Fortunately, with the small spaces, most of the time that's your occupant sensor that's takes the place of your light switch on the wall. So, all right. And with that, I'm going to turn it over to Sean to look at some of the comparisons of our lighting controls and helping to show how similar they are, even if they're laid out a little different.
All right. Well, thank you, Ryan. Well, really digging into the layout differences here to start off with. With ASHRAE, um, again, we had a list of different control requirements, and then for each space type, you've got a table that you look up which requirements apply to that space. Where in the IECC, it's more of a narrative layout of what those requirements are. So here what we're going to do is just kind of connect these different components together. So the IECC occupant sensor controls tie into the add one and add two requirements for automatic control of lighting. So like for the IECC, occupant sensor control shall have automatic off. Um, they shall have manual on or partial auto on. So that goes to the add one options in ASHRAE. For the turning off the lights automatically, IECC again has for certain spaces, lighting has to turn off at least 50% with daylight partial off controls. That can be fully off as well as a means of complying with that automatic partial off requirement. In ASHRAE, however, they do require an intermediate step for that automatic partial off, somewhere between 70 and 30%. So they do have an additional requirement there that's not in the IECC. Certain spaces can have a full off allowance. But in general, there is that added requirement in ASHRAE. There has to be an intermediate step where IECC, you don't necessarily have to have that intermediate step. Looking at time switch controls, this ties into the I and J requirements for ASHRAE for scheduled off requirements. The main difference between the scheduled shut off and scheduled off during non-business hours is application in ASHRAE, whether it's using a time switch control or some other method of turning off that lighting. The next step to look at is light reduction controls. Again, this is that bi-level lighting control I was talking about earlier. When you have a requirement for light reduction controls in spaces in IECC, you can turn off to that 50% level or go to full off. That qualifies as, that intermediate lighting step. For ASHRAE, you do have to have an intermediate step for that bi-level lighting of full on, some intermediate step between 30 and 70%, and then full off. For daylighting controls in the IECC, that ties to the E and F requirements in ASHRAE. So ASHRAE's split that section up into daylighting required for vertical fenestration and then for skylights. In the IECC, they're grouped together just as the daylight responsive controls section. Manual controls ties into the local control of ASHRAE. The requirements are very similar there. As Ryan touched on earlier, there's a slight difference in the square footage application between those, where ASHRAE's got a couple of steps that IECC does not. And then lastly, exterior lighting controls. These are very similar between the two. So just looking at them in detail, controls fall into kind of these three main categories in the IECC. You've got that local control, which is pretty much required in every space. And then you've got occupancy and vacancy based control with the automatic off or timer controls. And then you've got light level controls through daylight sensors and the light reduction control requirements. Looking at ASHRAE, again, very similar breakout. Local control is pretty much always required in spaces so that occupants have that manual control capability. Um, then you've got the occupancy and vacancy-based control components. And then lastly, your light level controls and daylight harvesting requirements. Daylight and dimming, similar to the IECC, work together because photo control should reduce electric lighting power in response to available daylight using continuous dimming down to 20% or less, and then off. There does need to be a full off option. But in the case of ASHRAE, daylighting controls must coordinate with bi-level lighting controls. This is another additional step in ASHRAE that's not tied in IECC. If you've got the dimmer or other bi-level control that's requiring lighting to be at a reduced lighting level, your daylight can't then adjust the lighting above that required level, and vice versa. If your daylight sensor is dimming the lighting, your bi-level controls can't then turn on lighting beyond that required lighting level that the daylight sensor is asking for. So there's a little bit of control complexity introduced here it's trying to maintain that lighting efficiency, but it does add a little bit of complexity in your control requirements. So again, thinking back to our IECC example for the meeting room, we're going to look at it here on the ASHRAE side. For conference or meeting space, the space is going to have automatic partial off control per the table shown here. And then daylight responsive control must continue to control the lights, but it must stop adjusting lighting power above that automatic partial off set point. So this is kind of that interaction we were talking about. The IECC states that that bi-level control needs to decrease lighting to at least 50%. So off is at least 50%. That's a valid state. Again, ASHRAE requires at least that one intermediate step between 70 and 30% or continuous dimming capability. Coming up new in the 2021 IECC, compliant light reduction options are going to be a little bit more clearer and more in line with the LED era. So lighting power densities are going to get a little bit lower. Control options are going to get changed a little bit to account for the efficiency of LEDs. These options are going to include continuous dimming of all luminaries from full down to that 20% lighting power and then full off, and switching of all luminaries to that 30 to 70% of full power. So it'll be more in line in the 2021 IECC with these ASHRAE requirements. What we're calling out here again is that for a conference or meeting room, that bi-level lighting control requirement is there required for that space. So looking at our example conference room, kind of going through the IECC process flow here again. IECC is going to require occupancy sensors for a conference or meeting room. It's on that list of required spaces. And then since that space is larger than 300 square feet, but it does have that unpredictable occupancy, as Ryan mentioned, it's going to require that occupant controls with that 50% limited automatic on requirement. The big difference between ASHRAE and IECC here for this particular space is that in the IECC, there's not a requirement for that lighting level control if automatic on is used. So where ASHRAE requires that mid-level step between full on and full off, IECC can allow full off control there. Here, looking at the daylighting control requirements for the IECC, again, as Ryan covered, in the IECC, the daylighting controls is looking at the individual area of fenestration in that space. So as long as an individual window isn't greater than 24 square feet or under a skylight, then the daylight controls were not required for that conference space. In ASHRAE, however, it looks at the total fenestration area serving that space, not the individual window units. So in the ASHRAE example, it would actually require daylighting controls in that space, um, just based on the fenestration area. But then looking at the controlled lighting within the control areas, because it's less than 150 watts of lighting in each daylit area of those windows, it would be less than 50 watts most likely. You probably only have one fixture served by the daylight area of each of those small windows. Then daylight controls would not be required. So it's same net result in the end, um, but slightly different pathway to get there. And again, we like to note that the IECC does have an additional exception that's not in ASHRAE, and that if you can reduce your lighting power density by at least that 40%, then you're not required to have the daylighting controls. So again, accounting for as we get more efficient with LED lighting, there's diminishing returns on having additional controls of more efficient lighting. You can save that capital cost for the building by going above and beyond on reducing the installed lighting power, to then avoid having to put in additional controls. So again here, really touching on that bi-level lighting control for lamps with daylight control. Since occupant sensors are required in this space, it does have that step off requirement for light reduction controls. Um, Again, in the IECC, that step can be at least 50% or full off, because that falls in that at least 50% requirement. For ASHRAE, you do have to have that intermediate step between 70 and 30%, or a continuous dimming for those light reduction controls. Uh, so looking at occupancy sensing requirements, this is again the list of spaces in the IECC where occupant sensing devices are required. Um, for most buildings, this is going to be almost every space in the building. New to the 2021 IECC corridors, they're going to be specifically listed as one of the applications requiring occupant sensors, and they'll have their own section with specific requirements for lighting level controls tied to those occupancy sensor requirements. Uh, unless the corridor is lighted with a bare amount of illumination required for safety, that bare minimum safe passage lighting requirement, then lighting power must be uniformly reduced by no more than 50% within 20 minutes of that hallway being unoccupied. And we do see this applied in some buildings already, but this is now making it a prescriptive requirement. Something that's slightly different in ASHRAE than IECC when looking at daylight zone definitions. ASHRAE has incorporated a definition for multi-story spaces on what areas are going to qualify as daylit areas. So on the first floor, underneath a skylight assembly in that atrium space, it's going to be the normal definition. But as you go down through the atrium, as floors kind of block off that light level down to the subsequent spaces, you narrow down that daylit area that falls into the requirements for daylighting controls. So this adds a little bit more clarity on how to apply daylighting controls to a multi-level, multi-story space that's not currently in the IECC. Some slight differences in daylight zone definitions. Here, ASHRAE accounts for projection factor for side lighting calculations that the IECC does not account for. IECC has a specific area that counts as side lit area based on the height of the window from the floor to the top of the fenestration assembly laid down into the floor plan. That gives you your daylit area out from the wall, and then 2 foot on either side of the window. For ASHRAE, it's slightly different, and they do have this projection factor adjustment incorporated in there. Um, ASHRAE also has a secondary side lit space defined as well. Um, and so when looking at the primary side lit area, that's that area laid down just as in the IECC definition. You take the window height to the top of the window above the finished floor, lay that down onto the floor plan. That's your primary side lit area. The secondary area is just taking that area and duplicating it again more towards the core of the building. So essentially double the window height into the space. Um, the threshold for controls in that secondary daylit zone is a 300 watt or greater lighting power density in that combined primary and secondary daylit zone. If you got less than that, then that secondary zone isn't triggered. You just have the primary zone. Coming in the 2021 IECC, it's also going to start identifying secondary daylit zones, which is going to potentially double the reach of daylight responsive controls requirements in buildings. The 2021 IECC is also going to recognize rooftop monitors as producing side lit illumination. And we'll start incorporating projection factor shading effects into those daylighting requirements. So the IECC in the 2021 version is going to be coming more in line with the ASHRAE requirements you see here. Again, for both ASHRAE and IECC, photo control is going to reduce that electric lighting power in response to available daylight using continuous dimming down to 20% or less and then off. Again, making sure that lighting isn't going to be continuing to operate at that 20% burning energy when it's not needed. It should be able to turn completely off. That 20% dimming limit is usually tied to fluorescent lighting and their ability to dim. With LED lighting, you should be able to get much closer to continuous dimming all the way down to off. But again, that last 20 to 15% lighting dimming in a daylit space, you're not really going to notice that light just turning off below that 20% requirement. Spaces with 300 watts or more of general lighting within the combined primary side light and secondary side light areas. The general lighting in that space must be controlled separately to reduce the electric lighting. So your secondary area is likely going to be turned back on by your photocell controls before your primary. Again, it's just accounting for these are two separate zones that need to be controlled. They're going to have slightly different requirements for lighting levels and how much daylight's going to penetrate through into that space. And then again, when looking at automatic partial off control with reduced lighting power densities, reducing that lighting power to the unoccupied set point in accordance with section 9.4.1G. Daylight responsive controls shall adjust that electric light in response to available daylight, but should not allow lighting power to go above that reduced lighting power set points. This is that interaction I was talking about before. And vice versa. If daylighting is reducing your lighting power requirement below what your partial automatic control set points are, your automatic control shouldn't then override your daylight sensors. The lighting should always be at the minimum lighting power to meet the lighting requirements of the space. And there does need to be some interaction between the controls to achieve that. So we saw this chart with the simplified building method again. Now we're just bringing it up again to go over the building area and space by space methods. Generally, these requirements are the same as the IECC as far as the spaces included in them. The building area method spaces are the same, and the space by space method spaces are the same because they come from the same general resource. Interior lighting power density requirements for the building area method is generally going to give you a lower lighting power allowance. Space by space method is generally going to give you a little bit more lighting power allowance. And with the ability to trade off between spaces, you get a little bit more flexibility in your lighting layouts with the space by space than you do with the building area method. When looking at the lighting power density allowance exceptions, they're going to be a little bit different than in the IECC. Lighting equipment and application exceptions are permitted under exception 9.2.3.1 listed there. ASHRAE allows extra lighting power allowance, as Ryan covered earlier, for additional controls beyond the minimum requirements. In the IECC, it's inverted. If you install additional controls, you can reduce your or increase your lighting power allowances. So ASHRAE allows the extra first and then the additional controls to compensate. IECC gives you the higher lighting power density. Allows that higher lighting power density if you install the controls. So essentially they come out to about the same, but they are worded differently. Looking at manual on, auto on, again, partial manual on is required in most spaces, given that manual requirement to occupants. For auto off, again, just kind of drilling in here, when you're doing that stepped off control, you can have automatic full off, partial off, or scheduled off requirements. Very similar to the IECC, and daylighting controls going to be fairly similar between the two as well. I think we have another poll here. So for bi-level lighting controls in ASHRAE are more specific, requiring a setting between 0 and 100%. Is that true or false? And then which code allows an exception for daylighting controls for a total lighting power density in daylit zones at least 40% below the code maximum? Is it ASHRAE, the IECC, or both? We had a couple of comments come into the chat. Any key areas that are overlooked or calculated incorrectly that need special emphasis at plan review? I'm not sure. Ryan, have you run across any particular issues?
Yeah, a few different things to look at. First, when we're looking at occupant sensing controls, as Sean alluded to earlier, most all spaces are required to have occupant sensing controls, with a few exceptions at the present time. Again, that list continues to expand and expand. At some point, that we'll just say, just put them everywhere and we're done. But as far as daylight harvesting controls, one challenge that we see is the daylight zones not being identified, which should be identified, and so that the plan reviewer can verify if you have crossed your wattage thresholds or perhaps your watt per square foot. Again, as Sean mentioned, with IECC, if you drive down your lighting power density, you can avoid having to install daylight harvesting controls, whereas in ASHRAE, that's not quite the same. So I think those would be the two things to check: is have they put occupant sensors pretty well throughout the building, and wherever they are not, that either needs to be identified as safety, is there a particular safety issue that they're addressing, or it's on time switch controls. So that's some things to check.
Okay, so going over our poll questions here, the bi-level lighting controls in ASHRAE, are they more specific, requiring that setting between 0 and 100? It's true that they are more specific. It's not true that it's between 0 and 100. It's between the 70 and 30%. So a little bit of a trick question there. We'll give you to both people there, I think. Depends how literally you read that question. And then question 2, which code allows the exception for daylighting controls if your LPD can be reduced by 40%? That is the IECC. That is not in ASHRAE. think it's time for Ryan to take over and talk about some lighting power density comparisons.
Okay, yeah, let's take a look at lighting power density. So there's some differences for dwelling units. This is one where ASHRAE has a threshold of at least 75% being high efficacy lighting. IECC presently is 90% of fixtures have to be high efficacy. Uh, and something to be aware of is as we move to the 2021, 100% will be required. So that's something there's a little difference there, how much can be not high efficacy lighting. At this point, it's not terribly hard to achieve high efficacy lighting because LEDs have gotten pretty good. Even when we did our market basket analysis a few years ago, we found that 85% of the products on the market met high efficacy lighting. So, and it generally was the higher end fixtures that were not meeting the requirements. So they may have been a little more specialty and things like that. So that is one little difference, is a little more stringent on the IECC side of things. So as far as some of the exceptions to the lighting power density, so here ASHRAE has this table of exceptions for this. Note that this does not qualify in the simplified method. So this is presented a little different between ASHRAE and IECC. So here in ASHRAE, these are the, they present this here as exceptions, but then also notes as far as any controls that are required for these. Whereas if we move over to the IECC, they just list, here's what's not counted in your lighting power density. So IECC does not call out separately as far as the controls for these lighting requirements. And as you kind of see from both of these lists, this is for other purposes. These are not general area lighting, TV broadcast and food warming, photography, for photographic purposes, things like that. So, and with that, here's a look as far as this is for the IECC lighting power density. We see in the building area method, they just have one for hospital, one just over 1 watt per square foot. Whereas in the space by space method, as mentioned earlier, you have to break it down into each individual category, your exam rooms, medical supplies, patient rooms. And so you'll see several, some of these are less than the 1 watt per square foot, medical supply and patient rooms, which hospitals have a lot of patient rooms, are much less than one. Then you've got ones that are over one, the exam room and particularly the operating rooms. So overall, you're probably going to come out fairly similar. Might be a few percent difference, but not dramatic. So if you need that extra budget, then maybe you do the space by space method. But at this point in time, again, because LEDs and what's available out there, meeting the building area method generally is not too difficult. So here we see a little bit of a difference for the building area method. What we see here is ASHRAE is a little bit more stringent. However, again, with ASHRAE, they say if you add more controls, then you can have a little bit higher lighting power density. So you can get there, whereas the IECC says if you get your wattage down further below this budget, then you can drop controls. So they're very similar end result, but how they get there is a little different. And so that's where if you do check the tables, you will see that generally speaking, IECC gives you a little bit more leeway. So IECC also has a specific thing for lighting controls. This is for open plan offices. What's the different zones and reduced lighting power. Uh, as a zone is unoccupied, then you have to get at least 80% of the lighting in that zone uh, dropped off. And then once all the connected zones in that office, that open office area are unoccupied, then the remaining 20% have to drop. So uh, understanding, it's probably easier in that case that when the sensor just controls everything in that zone, and when it's unoccupied, it's dropped off. That way you're not having to network the controls between each other, which can be much more difficult when you get into commissioning and maintaining that. So ASHRAE does it a little bit different. Again, here it just says can go automatically on to no more than, or they can go on more than 50%, but the control zones have to be 600 square feet or smaller. Understanding that in an open plan office, it's not terribly logical for someone to have to interact with the lighting controls because these are large open spaces generally. So that can make it a little hairy that way. So time switch controls in IECC. Here we're calling out that if you don't have an occupant sensor, it's going to need a time switch control. And if you have time switch controls, then you have to have your manual controls. So, whereas ASHRAE does this a little bit different. ASHRAE, Sean mentioned, you do have there is a nominal amount that you are allowed to leave off of time switch controls. This is going to be predominantly your egress lighting, 0.02 watts per square foot. So that's one fixture, a 20 watt fixture for every 1,000 square feet. So that's that's going to be very minimal lighting that you have for that. So with that, that's definitely one of those that being aware of that. IECC, they kind of deal with that just through their exceptions, saying if you have safety or egress lighting, that does not have to do time switch controls. So light reduction controls, I know we've touched on this earlier, that light reduction controls to allow the occupants to reduce the lighting by not less than 50%, with a few exceptions. Probably one of the easiest ones to look at for there. Space is under 0.6 watts per square foot. Again, with current technology, we're seeing designs somewhere in the quarter to a half a watt per square foot. So you may be able to avoid the light reduction controls. You'd still have your time switch and occupant sensor, but not your light reduction controls for that. Whereas, again, ASHRAE, there has to be at least one step between that 30 and 70%. Generally, it's 50%, but it doesn't have to be for those light reduction controls. Daylight harvesting, this is another one that's been being worked on over time. The IECC actually has some very nice drawings in the code document, which is available online, showing that head height flopped in, and then here 2 foot on either side of the window. So again, these are very similar between ASHRAE and IECC. ASHRAE sets that limit of 20 square feet, IECC at 24 square feet of glazing area. So few little differences here and there. But overall, we have seen these, the ASHRAE standard and the IECC code coming more and more alignment over time. So here looking at top lit, and this is 70% of the ceiling height for each side. So, and here understanding there's just a nominal difference between the two. For the skylight aperture, you know, 0.006 versus 0.008. So just very, very minimal difference. Um, but IECC does have a lighting power density calculation. So if you do, again, if you're able to drive down your watts per square foot, you can avoid having the top lighting thing. So we do like to hit on this and make sure that people are aware. If you do get your lighting down by 40% of the weighted area, then you don't have to add your daylight harvesting controls because you took the watts out to begin with, so you got your savings without having to add more controls. We do like that because the simpler things are, the more likely they are to be able to be maintained that way. And again, 40% we are seeing this able to be achieved without too much difficulty. Here's a brief example as far as what that looks like. So 40% reduction of the weighted area. So if I have half the area in a daylit zone, I got to be down by 20% overall. And if I have only a quarter, then I have to be 10% lower overall. So is 1/4 of 1/4 of 40% is 10%. So if I'm below that threshold, I'm done with daylight harvesting controls. Don't have to buy them, don't have to install them, don't have to maintain them. So with daylighting zones, again, looking at it and saying, well, regardless of if you're controlling it through a time clock or an occupant sensor, you still have that 150 watt threshold. And if you have if you're going to control banks of lights together, they have to have similar ambient light profiles. So you can't have control the east facing lights with the west facing lights because those have very different ambient light conditions. So just wanting to make sure that whatever you're controlling does kind of make sense together. You don't want to leave some people in the dark while others are in plenty of light. So as far as lighting retrofits, ASHRAE sets this limit at 20%. So if you are altering less than 20% of the fixtures in a space, then you don't have to add your controls. And they also have a provision where if you're just doing a lamp and ballast change or 1-for-1 luminaire replacement, then you're just checking for your lighting power density requirements. And do you have your automatic off or timer off controls? So yeah, ASHRAE has that 20% threshold and a 1-for-1 swap is allowed. IECC, that's a 10% threshold in order to not trigger that, and also has that bulb and ballast within the existing luminaire allowed. So we don't see too many issues with or too many times when lighting retrofits you do have to have a full replacement, predominantly because many times if all you're doing is a lighting swap, that's not requiring a permit from the local jurisdiction. So if all you're doing is bulb and ballast within the fixture, that's considered a repair and therefore generally not required. So here looking at an office retrofit for a 5,000 square foot. They're moving in. They're going to be upgrading luminaires and things in some private offices and a conference room. How does this apply? And kind of what it looks at saying is saying whatever you're touching, that needs to comply. So just because you're doing a lighting retrofit doesn't mean you have to insulate the walls, but you do need to bring the lighting up to up to the standard in the spaces you're doing it. So if all you're doing is offices in the conference room, that's all you have to worry about. You don't have to worry about the open office area that you're not touching. So, um, and similarly, when you're dealing with outside and parking retrofits, you know, if you're leaving the existing housing and all you're doing is a lamp and ballast, then you're not having to deal with anything else. May be aware as far as particularly for lighting retrofits, if they are on a timer, but they don't have photo controls, we would highly recommend, even if it's not required, to go ahead and add your photo cell and photo controls for those, because heat is really what kills LEDs and electronics most of the time. So if you can avoid having your lights on in case something goes wrong, avoiding having your LEDs on in the heat of the day is definitely good. So being aware of that. And track lighting is one other place that you'll see a huge difference between ASHRAE and IECC. ASHRAE, it's 30 watts per linear foot of track is the basis of the lighting design. And then IECC, the minimum threshold is 8, or your connected power, whichever is greater. So if you've got an 8-foot track, an ASHRAE, that counts for 240 watts of your budget. In IECC, that's only 64 watts of budget. So with that, I believe we do have one final poll question. So looking at a lower power allowance in ASHRAE is necessarily stricter than a higher allowance in IECC. Yes, it always is. It depends on your controls selected and room geometry. So is your lower, since ASHRAE has a lower power allowance in the table, is that always stricter, or is it sometimes not, depending on your controls? And number 2, wanting to learn a little bit more as far as, have we helped your understanding of ASHRAE 90.1 or IECC? Yes, very much, somewhat, or not so much. I don't think we saw any other questions come in, but again, if you do have any questions after today's presentation, this will be archived onto our website. Again, feel free to visit us, smartenergy.illinois.edu/energy-code. So that will be where our archived version of today's presentation, along with the PDF of today's slides, will be found at. So,
I'd also recommend we've developed a module on our Thinkific webpage that goes over the IECC and ASHRAE comparison. I think better lays out the examples comparing the IECC versus ASHRAE requirements. So I would recommend looking at that Thinkific module for those particular example details.
all right. And so, yes, most everyone picked up on, yes, just because ASHRAE lists a lower lighting power allowance doesn't necessarily mean it is stricter. So it depends on what your controls and room geometry is. So with that, I do want to thank everyone for joining us today. Feel free to reach out to us, energycode@illinois.edu, and everyone have a great afternoon.